Hey everybody, we're on 10.5 Trig Applications. Before we get any further, we need to talk a little bit about the words angle of elevation and the angles of depression. All right, so let's just kind of do a little sketch of what's going on. If you were sitting up on this grassy knoll and you have a friend that is on this lower portion, so that's you, and you're looking down, and here you have your friend who is looking up, okay? The angle of depression is this angle, and the angle of elevation is this angle, all right? As you notice, those angles are alternate interior angles. So the angles are the same. So whether or not it's depression or if it's elevation, the angle is always the same. So when we sketch these triangles, we can always use, like if that's the triangle we draw, whether or not we're saying depression or elevation, we can place our angle here. All right, that's what I'm trying to say here, okay? So that angle is always the angle that touches the horizontal side. We'll never do the one that is the angle using the vertical angle. So this angle, if we were to label this, this would never be the elevation of depression or elevation. Okay? All right. Okay, so let's do a couple problems. Just a reminder, the best way to tackle a word problem is to draw it. Okay, so let's see what we can come up with. It says a meteorologist reads a radio signal to get information about a weather balloon. So again, all of our triangles are right triangles, and we can always sketch it like this if we want to. So here I'm going to sketch my balloon. That's my weather balloon. Okay. It says the last alert indicated that the angle of depression of the weather balloon to the meteorologist is 41 degrees. Okay. So again, elevation or depression, we can always use this angle. It's always the angle that is touching that horizontal, not the vertical, the horizontal. So we could say that this is 41 degrees. Okay. And the balloon is 1,810 meters away on the diagonal. So this would be 1,810 meters. Okay. To the nearest meter, how high above the ground is the balloon? So we're trying to figure out what this is. Is this height? All right. And this is, maybe we'll sketch this meteorologist. All right, so you've done problems that are just like this before. Again, we want to label the sides. We have our reference angle. This would be our opposite. This is our hypotenuse. Which trig uses opposite and hypotenuse? Well, that would be sine. That's our so for SOHCAHTOA. So sine of 41 is equal to opposite over hypotenuse. Okay. We need to solve for x, which means we need to multiply both sides by 1,810, and we get x by itself. So we'll get x is approximately equal to 1,187.47 meters. Okay, so again, a lot of these application problems is just realizing that it's the same as what we've been doing. We just need to identify where things go. Okay. All right, let's do another example. So a ladder is leaning against the side of a house. So that kind of makes a triangle. That's nice. So we have this triangle. And maybe I'll make it look like a ladder, maybe. okay? And it says it forms a 65-degree angle with the ground, so that's important. The foot of the ladder is 8 feet from the house. So the distance from the foot of the ladder and the house is 8 feet. Find the length of the ladder. So this is our x that we need to find. Again, we need to label our sides. So this is our adjacent side and our hypotenuse. So that means we're going to use cosine. That's our SOHCAHTOA. So cosine of 65 is equal to adjacent over our hypotenuse. Okay? All right, and this is going to take us 2 steps because x is in the denominator. We'll multiply both sides by x, and then we'll need to divide both sides by the cosine of 65. And we'll get x is equal to that. So we'll plug that into our calculator, and we'll get x is approximately equal to 18.93 feet. All right. So why don't you give this one a try by yourself? A tree has a shadow that is 16.5 feet long, and the angle of elevation from the end of the shadow to the top of the tree is 58 degrees. How tall is the tree? So pause and give us a try. Draw your triangle, label the information, and do all that. All right, so here is my tree. Good tree, huh? Okay, and it has a shadow, and it says that the angle of elevation from the end of the shadow to the tree, so it's basically saying that this is our angle of elevation, is 58 degrees. And the shadow, it said, was 16.5 feet. How tall is that tree? Okay, so we'll label, that's our opposite and our adjacent. So we'd use tangent, our TOA for SOHCAHTOA. So tangent of 58 is equal to opposite over adjacent. Okay, we need to get x by itself. So we'll need to multiply both sides by 16.5. And now we have x by itself. We'll plug that into our calculator, and we'll end up getting x is approximately equal to 26.21 feet. All right, so all of those problems, they've been giving us a side and an angle. So we've had to use trig. Some of the problems, x was on the top, so it was just one step to multiply to get x by itself. Some of the problems will have x on the bottom in our denominator, which means we'll have to take 2 steps. We'll need to multiply both sides by x, and then divide by whatever sine, cosine, or tangent is being used. Okay? All right, then we have 3 others that are a little different, and we'll see why. But we'll still set up the same way. We need to write our triangle and label all of our information. So the height of a tree is 15 meters. So we know the height of that tree is 15 meters. To the nearest degree, what is the angle of elevation of the sun when the tree casts a shadow that is 9.3 meters long on the ground? So here is our shadow. Okay, over here we have our sun that is causing that shadow. All right, and they want us to know what that angle of elevation is. So that's our theta. Okay, so again, that's the tough part, is sketching that out, and then it's the same as what we've done before. Again, we label our sides, so that's our opposite and our adjacent. So we'll use tangent. So tangent of theta is equal to opposite over adjacent. And we'll need to solve for theta. So again, to cancel out a tangent, we need to do a tangent inverse. And that's what we'll get. We'll plug that into our calculator. We'll get theta is equal to, or approximately equal to, 58.20 degrees. Make sure you mark the degrees that we're talking about degrees, okay? Use those units. Okay, why don't you give 5 and 6 a try? You can skip over the work and just see what the answer is, and you'll see where you're at, okay? All right, so a diver wants to visit a shipwreck that is 650 meters below the water. So here is my water. Nice water, huh? And then over here, that is 650 feet below the water is this shipwreck. And I'm going to do my best. This is my shipwreck under the water. Okay, that's my boat. Okay? All right. It says there is too much danger to start diving directly below the wreck. So we can't just go straight down. The diver jumps from the boat and swims diagonally 953 feet to reach the wreck. So basically he has to swim a longer distance going diagonally to get to the boat. Maybe we should put units. So here is the other boat that's not shipwrecked. Okay? And then it says, what is the angle of depression from the boat to the shipwreck? So this angle. Again, the angle of depression or the angle of elevation is always the angle that touches the horizontal or uses the horizontal line. So we need to figure out what this is. You could sketch this up differently. I've had other people have the boat this way and have it measured this way, 650 and 935, and then that's what we'd use for our angle of depression or elevation, depending on what way you're looking at it, okay? Okay, so let's label the sides. Here we have our hypotenuse and our opposite. So we'll do sine. Sine of theta is equal to opposite over hypotenuse. Again, we'll need to do the sine inverse. So we'll get theta is equal to sine inverse of 650 over 935. All right, and we'll get theta is approximately equal to 44.04 degrees. All right, pause again if you haven't done this yet. Give this one a try. So we have a ladder, so most likely we're going to have a ladder something like this. This is maybe your ladder. Okay, resting against a wall. The base of the ladder is 6 feet from the wall. So this is 6. What angle does the ladder make to the ground? I didn't mark this down. That was an 18-foot ladder. And the angle makes with the ground. So this is the theta we're looking for. This is not the theta we're looking for. Okay, so label your sides. So we have our hypotenuse and our adjacent. So we'll use cosine. Cosine of theta is equal to adjacent over hypotenuse. And you solve for theta. I'm okay if you just set it up straight away and just do cosine inverse. Since you know we're solving for an angle, we'll need to use the inverse. Okay, and we'll get theta is approximately equal to 70.53 degrees. So that is using trigonometry to solve application problems. All right, if you have any questions, please let me know. Next up will be our review and then our test. All right, we'll see you guys.